Hello viewers, welcome back to my channel Learn with Ravi. In my previous video of mine, I began with the concept of ratio and proportion. Now what is variation? Variation is a case where a variable value depends on the other variable value. Like for example, if P and Q are two terms and P may be related to Q in such a way that the value of P gets modified depending on the value of Q modifications. Now we have three types of variation. The first variation is direct variation, second one is inverse variation, third one is joint variation. I'll give you an example. In the first example, if x depends directly on y, that is if the value of y increases and if x increases, if y decreases and x decreases, then we say that x varies directly with value of y. So y is called as independent term, x is called as the dependent term. So we write x equals to k into y, where k is called as constant of variation. So when you write x1 becomes ky1, x2 becomes ky2. The value of k will never change. So if x1 is ky1 and x2 is ky2, dividing them, you get x1 upon x2 is same as y1 upon y2. Similarly, in the case of inverse variation, we say that if the value of y increases, if x decreases, if y decreases and x increases, then we say that x varies with y inversely. And from this case, we write x equals to k times y, x equals to k upon y, and you write x times y is equal to k. So x1 y1 will be k, x2 y2 will be k. So you write x1 by x2 is same as y2 by y1, or when you cross multiply, x1 y1 will be same as x2 y2. Now in the case of joint variation, we have a case where a variable value depends on multiple variables, like if x depends on y and if x also depends on z, either directly or indirectly. We write as in the example on the screen, you see that x depends on y directly and x depends on z inverse. So you write x is proportional to y directly and x varies with z inversely. So you say x varies with y upon z. So from that you can write x1 by x2 is same as y1 z2 upon y2 z1. So variation is a concept where we correlate the dependencies, nothing more than that. Now let us try to solve some problems using this concept of variation. The first example goes like this. The force of attraction between two bodies varies inversely as the square of the distance between them. Read the first statement carefully. He says that the force between the bodies varies varies inversely with the square of the distance between them. And when the distance is 2 feet, the force is 18 newtons. Then what is the force when the distance is given to us? Now from the problem, it is clear that if F1 is 18, D1 is 2, and if D2 is 3, what is the value of F2? Now given that F varies with D inversely, so we say F equals to K by D square. Yes or no? So we get F1 D1 square equals to F2 D2 square. This is the case of inverse variation, right? So F1 D1 square is same as F2 D2 square. Plug in the values of F1 D1 D2, you'll get F2, and it goes like this. So the answer is 8 newtons. So what do you observe? If distance is 2, force is 18. If distance is 3, force decreases. Why it decreases? Because when D increases, F decreases. Hence it varies inversely. So the force is only 8 newtons. This is the concept of dependencies inversely. In the next example, a garrison of 1200 men is provisioned for 16 weeks at a rate of 20 kg per man per day. We have a garrison. What is a garrison? A place where you pool of people, and it has some 1200 men, and there is some food, and that food is sufficient for 16 weeks at a rate where a person needs 20 kgs per day. Seems impossible, but that's the problem given to us. Now if some more persons join the garrison, the provisions would last for only 12 weeks at a rate of 16 kg per man per day. So more men, the food is constant, so common sense says days will decrease. Now find the number of men joined. The problem goes like this. So we observe that the problem contains men, days in weeks, rate of consumption are, and the fixed food provisions. The food is fixed, right? Now it is clear that the number of days depends on number of men inversely. More men, less number of days; less men, more number of days, isn't it? Similarly, we observe that the number of days depends on the rate of consumption inversely, isn't it? If they eat more per day, the food will be enough for only less number of days. If they eat less per day, the same food will be enough for more number of days. So from these two, we observe that the days in weeks depends on men and rate inversely. So it's a joint variation. So we write it as d varies with m times r inversely. So from that we write m1 r1 d1 is same as m2 r2 d2. Now plug in the values of m1 r1 d1 m2 r2. Given m1 is 1200, r1 is 20, d1 is 16, and he says some more men joined, so 1200 plus x times 16 times 12. So from that find the value of x. Fine with that? So in this way we try to solve the problems depending on the dependencies, depending on the variation concepts. Is that fine? That's for now in the concept of variations and proportion. We'll see more in the upcoming videos. Put your thoughts in the comment section and I will be ready to share my thoughts. Fine with that? Don't forget to like, share, comment and subscribe. Thank you all.